Several new ROS users find it difficult in the beginning to differentiate between a ROS workspace and a ROS package, and also may find difficulties in understanding how to set up their first ROS projects. In this video, I'm going to explain the process of creating a new workspace and a new package so after installing ROS, we need to do a little bit of configurations to enable ROS in your Ubuntu operating system. So ROS will be installed in the directory opt ROS and then the name of the version. In this case, it's Kinetic, and here we can find the whole workspace for the ROS installation. So the workspace represents the working area, and any workspace would have a special file that is called setup. Okay, so we have setup.bash and setup.sh for different type of shells. And this file must be executed to enable the workspace. So the workspace is actually the working area that contains the file that we need to run ROS or ROS applications. So we need, for example, to run the setup.bash using the command source. So instead of writing this manually every time in a terminal, we should write it into the .bash rc, which is a file automatically executed whenever you start a new terminal. So the .bash rc contains several script commands that will be automatically executed every time you open a terminal. So in the home directory, we can type gedit.bash rc, and then we will have this file open, and then I'm going to write the command source/opt/ros/kinetic. This is the path to the workspace, and this is the file setup.bash that will be executed to enable the workspace. So here, if I type ROS-core before opening a new terminal, before the changes take effect, you will see ROS-core is not detected. Okay, same thing if I run ROS-cd, that takes me to the default workspace. Okay, it cannot be executed. Now, if I close this terminal and open another one, so the changes will be effective, and then I can make ROS-cd. It will take me to the default workspace. So this is now the default workspace. And also ROS-core, which starts the main node, is going to be working. However, when working with ROS, it is not convenient to work in the default workspace. The common practice is to create your own workspace where to put your ROS projects so that your ROS code and programs will be in a workspace different from the default one. And for this, we need to create our own workspace. So let's see how it works. So let me first go to the home directory. So this is our home directory. And basically, we need to follow the instructions in the ROS tutorials, create a workspace for Catkin. In a nutshell, Catkin is just the compilation framework used by the ROS environment. To create a Catkin workspace, so it means the workspace where we are going to set up our projects and put our files, we're going first to create a new directory in the home folder, and the common practice is to put it in the home folder and give it a name Catkin WS for Catkin workspace. You can give it any name of your choice, but this is the common name in ROS. And then we will create also the src folder, which is going to be the folder that will contain the source file of your code. It will contain the ROS packages that you will create later on. So first of all, workspace, let's say this is a big area. You can consider it as like a big table where later on you're going to organize your projects, which we are going to call them packages, into this workspace. So we can say that a workspace is a complete working environment, and packages will be your own individual projects that will be put inside the workspace. So let's create the directory, and now we can go to the directory Catkin workspace, and finally we can compile the workspace using the command catkin make, and now the workspace is created. So after compilation, we have now created the Catkin workspace into the home directory, which contains also a build, a development, and a source folder. So you can see now, if we make ROS-cd, which is the command that takes you to the default workspace, it is going to take us still to the default workspace /opt/ros-kinetic. Even if I close and open again, so you can see the new workspace is still not enabled. In order to enable the workspace, we must also source the setup.bash that is located in this workspace, and we can find it into the devel folder. So here we have setup.bash. This one must be sourced to enable this workspace to be the default one. So how to do this permanently? We go to gedit.bash rc, and we need also to do a source home/riot_u. This is the name of the user, and so now this is the home directory. This is our Catkin workspace that we have created, and this is the devel folder, and finally we execute the setup.bash. Okay, so now I enable this instruction, and now I will open a new terminal. So you can see now, if I make ROS cd, it's going to take us by default to the Catkin workspace that we have created right now. Why? Because this one was sourced after the default one. So you can see now, if I go back to gedit.bash rc, I am printing the ROS package path, which is shown here. This is now the default one, and this is the workspace of the installation. Now that you have created your workspace, it is time to start creating your ROS projects. So a ROS project is actually called a package, and a package is defined inside a workspace as a location where to create the files and the programs of the ROS project. So first of all, we need to go to the Catkin workspace, and as you already know, the Catkin workspace contains 3 folders. One for the build that contains the compiled files, one for the development, and one called SRC for the source files. So our packages or projects will be created into the SRC folder. So let me go to the SRC, and then in order to create a new package, we need to use the command catkin create pkg, and then we specify the name of the package. In this case, I'm going to call it ROS basics tutorials. And finally, we need to specify the dependencies, which means the ROS libraries on which the project will depend. Of course, there are common libraries that we can include in the project since the creation time, like for example, standard messages, ROS.py for Python, and ROS.cpp for C++. We can include also other libraries, but at the creation time, we may not be able to know what are all the libraries that our project will depend on. So this is not a problem, because later on, when I will explain how to create new ROS applications and programs, I will also explain on how to add manually new dependencies into the project. So for now, it will be okay to just create the project with only these 3 dependencies. So now I will execute the command, and the new ROS package is created. But still, I need to compile the workspace to complete the creation of the ROS package. So to compile the new package, we need to go to the Catkin workspace directory, and then we use the command catkin make. So now our project is created, and we can go to the SRC folder, and we can check that we have already ROS basics tutorials created. Okay, this is Catkin workspace, this is SRC, and inside we have an SRC folder, and this is where to put the source code of the ROS programs that we will develop, and include here the place where to put libraries. For the moment, our source folder is empty, and we are able to create new programs here. So now we can use an integrated development environment to open this project. For example, I'm going to use Visual Studio Code, and you can use any other of your choice. Remember that you can refer to the video which IDE to choose if you want to have more information about the different possibilities available to develop ROS programs with different integrated development environments. So we can open Visual Studio Code, and then we can drag and drop the folder here. So we have here the source folder. Then we can create new files. Let me create, for example, talker.cpp. Listener .cpp. So just for illustration purposes, this is a sample code for listener.cpp, and this is another code for talker.cpp. Of course, I'm going to explain more in details the talker listener application in a later video, but just to show you how to create nodes and how to execute them after creating your workspace and your package. The next step is to add the compilation information into the Catkin workspace. So I will add an executable for the talker and an executable for the listener. Of course, this concept will be explained in the complete details in the lecture of how to implement a publisher and subscriber. So here, when we add the executable, we must make sure to specify the correct path to the node. So here, this is the path to the node talker, is src talker.cpp. So we go to Catkin workspace, src, ROS basic tutorial. So this is now the src file, the CMake list. So we have talker.cpp. And same thing here, src listener.cpp. After that, we can go to the Catkin workspace and finally execute the command catkin make. So now our two executable files are created and we can run the program. So first of all, we run the ROS core. Then using Ctrl-Shift-T, we open a new terminal. We can run ROS run. So the name of the package that we have created, which is ROS basics tutorial. And then we have two nodes. So let's start with the talker. Okay, the talker now is publishing. And in the second terminal, we run the listener program, which is also in the ROS basics tutorials package. And then we press listener ROS node. And we can see now hello world 11, 12. So you can see now 13. We can find 13 and so on. So this is a publisher is publishing, and this is a subscriber. So as I already mentioned, I'm going to explain in more details how the publisher subscriber works. It is just a matter of demonstrating on how to create an application right away after creating a workspace and a ROS package.